the chair of the Construction History Society of America. We are very thankful for all of you who are attending the webinar this afternoon. And again, thank you for joining us. So today, in commemoration of Memorial Day, is that we are use the topic of military architecture, and as part of to compose this webinar, and we have two excellent presenters today. We have Mónica Cejudo, who is joining us from Mexico, the National University of Mexico, and we have Ray Rawlings, who is joining us, if I understand correctly, from the East Coast. So, sorry, I'm a little distracted. I'm trying to do a couple of things here. So we are going to get started with the program. I'm going to introduce to you, the program is going to work this way, where I'm going to introduce Mónica. Mónica is going to give her presentation. Then I'm going to introduce Ray. He's going to give his presentation. Each presentation is going to take about 20 minutes. And then at the very end, we are going to leave about 10 to 15 minutes for any type of comments, questions that might emerge from the audience. And again, thank you very much for joining us. I'm going to just formally introduce Mónica. So Mónica Cejudo Collera has a bachelor in architecture and a master's on building conservation and a PhD in architecture at the School of Architecture of the National University of Mexico. She obtained her degrees with honors, in addition to obtain the Gabino Barrera Medal for the highest grades, for the highest GPA of her class in the bachelor's and the master's degree. Her doctoral dissertation was also published and awarded with the Francisco de la Maza Award. It's one of the most privileged, important awards in Mexico regarding to conservation and preservation of historic buildings, given by the National Institute of Anthropology and History, the INAH. And she also won the Premio Universidad Nacional in Architecture and Design in 2021. She is a full professor at the Graduate Studies Division of the School of Architecture at UNAM. And she's a member of the National System of Researchers, the SNI, by the National Council of Technology and Science in Mexico. During these last 30 years of her career, she has maintained a fruitful interaction between teaching and research, focusing on areas of architecture and military engineering, restoration and conservation of monuments and historic centers, and the history of Mexican architecture. So she has been published 5 books, more than 30 book chapters, 12 articles in academic journals, and 30 publications, memoirs, catalogs, broadcast magazines, and electronic media. We are very fortunate to have Mónica today with us. And without further ado, I pass the microphone to Mónica to hear her presentation. Thank you. Thank you very much, Mónica, for joining us.
Thank you. I'm going to start. Now it's on?
Yeah, you are on. You are on. I can see you.
Perfect. Thank you very much. Good afternoon. I'd like to thank you for being here, as well as Marion and Raymond Rawlings, and especially Dr. Benjamin Ibarra for this kind invitation. The issue will be addressing today is the importance of restoring and conserving military architecture and the challenges this involves. The pressing need to protect, restore, and valorize it, as well as broadening and consolidating research issues on this line. We shall analyze why it's important to preserve this heritage because of the contributions to architecture. To do this, we will explore different fortifications on the American continent, especially from the Caribbean and New Spain, in order to illustrate the importance of the work of military engineers for the history of construction work. I will also discuss the treaties faced by this architecture and review cases of the constructive contributions of military engineers. The concept of war for the pre-Hispanic world encountered by the conquistadors was the product of the coexistence of a large number of cultures in Mesoamerica, whose military structures were framed by their civil and religious organizations. Following a long, bloody war that lasted 2 years, they saw the fall of the Aztec Empire, giving birth to a new culture forged throughout mestizaje. New buildings began to be raised by indigenous hands on the ruins of the pre-Hispanic city, using materials from the demolished structures. The royal ordinances of Philip II for the urban layout of the Indies redefined the central plaza with a cathedral and city hall flanking the plaza. In this map, attributed to Hernan Cortés, we can observe continuous expansions and extensions in order to create more lots. The city's location on an island was a natural defense, with access easily controlled over 3 causeways. The urban layout on the capital of New Spain became a model for other cities, which repeated its unwalled nature, thus encouraging continuous growth. It required a supreme effort to protect an unknown territory without either the time or the resources to prevent pirate raids, nor plan cities that protected the inhabitants, without detaining the accelerated growth of their population throughout the arrival of new, diverse, and multicultural residents. The production of cartography fell to military engineers who, educated in the best European academies, had the knowledge, precision, and instruction in the use of measurement and tracing tools for their development. They also knew the treatises on military architecture that defined the required characteristics of the location and the distribution of cities for the adequate defense. The Renaissance vision that, in addition to being functional, oscillated between the scientific and artistic, and although the sources have focused on the construction and social analysis of defensive systems by engineers, these historical cartography show that the interpretation and knowledge of territory and the drawing of it was developed and enhanced by them. They had to overcome economic setbacks, rising needs for infrastructure and materials, preparatory work due to the complex local topography, and many other situations. Military engineers plan and supervise these projects for protecting cities and permitting the exchange of projects along trade routes through the continent. Also, these geographical expressions were used to visualize the area to attack. Math became the most effective way to meet imperial strategic needs. In addition to the ability that the military engineers had to draw, they had to follow the guidelines of the different ordinances, from the method of drawing of the maps and forming the plans, as well as the participation of the engineers in military works. This architecture became transcontinental in the mid-16th century. With the rise of piracy in the Americas, the Spanish crown saw the need to build structures and protect the ports, which became true walled cities. The value of the Spanish empire system of fortifications lies not only in constituting architectural heritage that it's preserved as an example of military architecture. In sites like Cartagena de Indias, Campeche, Havana, San Juan in Puerto Rico, Santo Domingo, Portobelo, Panama City, Santa Maria, Rio Hacha, Florida, the Araya Peninsula, and Isla de Margarita, and Veracruz, but also in the fact that its construction required European and engineer models and the interpretation of the military treatises of the period. A single military engineer will often be responsible for projects in many different localities, giving this to rise to typology and constructive invariance. They transform settlements, like here in Portobelo. Fortifications were laid out on a terrace that dominated the bay, thus constituting a defensive system by parapets, batteries, and redoubts. Military engineers also play a role in urbanism and civil architecture. Many notable government buildings were built in these early years. To reinforce the city fortification, military engineers built Fort San Lorenzo and a promontory of the river mouth to protect the embarkations heading from the Caribbean to the Pacific. The historic quarter of Panama has been preserved due to the presence of the wall. In Cartagena de Indias, walls were built facing inland, and its location along the coast protected it naturally from the sea. The walled city of Cartagena can be explained in geographical and geopolitical terms, as it was a point of support for the empire's communications and as a safe harbor. The formidable stone belt that surrounded and still surrounds Cartagena converted it into the second most military city in the empire after Havana. Cartagena boasts one of the most complete systems of military fortifications in South America. The presence of military engineers in Havana can be seen today at the entrance to the bay, with the emblematic Morro and San Salvador de la Punta castles. Havana is a natural port with a large enclosed base and a narrow access channel in which a chain was laid across for protection. Havana, with San Salvador de la Punta in a flat surface, trapezoidal design and bastions located at its four corners. The city of Santiago functioned as a communications port and as a support for the Spanish commercial fleet. San Pedro de la Roca is unique in the world due to its integration with the site, its dimensions, and above all, its defensive capacity. This military strategy and architectonic typology with an irregular polygonal structure overlooking the sea and bastions on land that are adapted to the site was also on the island of Puerto Rico. It should be emphasized that the defense system of Puerto Rico was the result of the evolution of artillery technology. It currently forms part of the U.S. National Park System. The island of Puerto Rico was a Spanish possession of great strategic value in the Caribbean, a characteristic that made it a stopover in the West Indian race. The city had to face numerous attacks, so the Spanish crown invested large sums in the construction of a complex defensive system. The first defensive works built in the city of San Juan, capital of the island, were made in the mid-16th century, but the defensive system of Puerto Rico was not completed until the end of 1998, when the island passed into the hands of the government of the United States. The system of defenses constructed in Puerto Rico followed the model of the military architecture developed in Europe during the modern age, and the nomenclature used in the fortifications responded as all the Spanish possession, as defender of the faith, so they had a religious name in order to endow them with a maximum protection. During this period of 395 years, numerous defensive work were built and the existing ones were reformed in order to adapt them to the new tactical strategic needs. When the defensive system lost the importance acquired during the preceding centuries, the situation caused some fortifications to be dismantled or even demolished. In New Spain, the most important forts were those located along the coast. The only fort that was of San Carlos de Perote. Cartography and the art of polyurcetics were at the height, as can be seen in the defensive evolution of San Juan de Ulúa, the first Mexican fort, built by Hernán Cortés in 1519 to protect Villarrica de la Veracruz. San Juan de Ulúa is located on the island of La Gallega, facing the city of Veracruz. Plans for a fort were drawn up with 4 bastions, making use of the existing Muro de las Argollas. In these plans, one can observe the church, the hospital, the plaza, the bridges, and the mayor's residence. The fort then began a long history of incorporating interventions and additions to improve its defensive capacity. Its defensive technique was finally perfected with Agustín Crame's detached exterior works, making San Juan de Ulúa into a typical well-rounded model of the military architecture of the time. This military enclave proved itself by holding its territory, which was admittedly lost in certain moments, but due to pacts between the Spanish crown and England rather than military invasion. Another reason to preserve this architecture is because it is a product of the trade relations that involve sharing objects that create culture with Asia. Remember that New Spain not only administrated the lands contained within its borders, but also the Philippine archipelago. The first global trade route, known as the Manila Galleon or the China ship, was maintained for 250 years. It required the protection and safeguarding of the ports of departure for the merchandise crossing the Pacific Ocean. The Philippines exercised a cultural influence on the rest of New Spain and left its mark on decorative objects such as the use of screens or the carved marble pieces with religious themes. Plants and fruits such as Manila mangoes and African tamarinds, dresses, shoes, parasols, fans and scarves, or paliacates, porcelain, piñatas, and rose, and all of them took root in Mexican culture, syncretizing with local productive traditions such as China poblana, whose spangled dresses have become emblematic of the country's culture. And cockfights, which have remained a folk tradition to the present day and are held in palisades like this. From Manila, the strategic position involved a direct connection to the colonial capital via the Acapulco Royal Road. Acapulco's San Diego fort, designed by Adrian Wood, had a pentagonal form. It was destroyed in an earthquake and was later rebuilt under the guidance of Miguel Constanzo, who repeated the pentagonal design but irregular. The fort's architectonic design was inspired by classical architecture treatises and was perfect according to the geometric and strategic considerations of the 18th century. The project's primary challenge was to utilize the resistance of the soil and its construction materials to ensure its durability and resist the area's seismic movements. The expansion of the bases of contact determined the width of the walls and defined the compacted earth platforms that were incorporated in the complex to ensure the stability the building required in this earthquake zone. The inclination of angle of the walls was determined by the angles of repose of the materials themselves, which allowed for a greater vertical load transmission capacity. Advances in the understanding of structural continuity were applied using fillings to better withstand the accelerations produced by this earthquake zone. Geometric rigor and design solutions create interior spaces resolved with barrel vaults. Ramón Pañón drew up this perfect design for San Diego, regular in the proportions and magnitudes. One side of his regular star with 5 bastions at his point faces the sea and the other side the land. The tops of the exterior walls are of special interest, made of stone with plastered finishes. The Fort of San Diego is currently home to the History Museum of Acapulco. This contemporary use allows the building to stay relevant within its urban context and aids in its preservation. Here, I feel it's important to say that we must avoid what happened in Mexico City, where these sentry posts and forts can now only be seen in the fantastic paintings by Carlos Nebel, who captured these military buildings as they were used to defend the city against the US Army. The city walls preserve the unity and design of the historical center of Campeche from the 16th to the 21st century. Planned as a walled city, the most important part in the province of Yucatan was attacked by pirates. Its system of fortifications is an excellent example of 17th and 18th century military architecture. Campeche is the only example of fortified city now in Mexico. Bacalar was part of the General Capitancy and Court of Guatemala, although it was considered a second-order territory due to the climate, humidity, and unhealthiness of the coast due to the British presence on the coast of Honduras. They promote the construction of forts such as San Felipe in Golfo Dulce, Guatemala, or San Fernando de Omoa in Honduras. And as in the river San Juan of Nicaragua. Sometimes these buildings are restored and given new functions as the shipyards of Veracruz to guarantee the permanence and conservation. As architects, we have the commitment to ensure the conservation of historic districts and raise the alarm about the challenges they face, like the political decisions made by those responsible for architectural heritage, who decided on the reconstruction of the walls, prejudicing the mobility of the inhabitants, the access of goods and services. Campeche's values lies in its status as an urban complex, the combination of formal, functional, and spatial elements that make it an exceptional place, not just for its military past. In Puebla, attempts to give new uses to the forts of Loreto and Guadalupe led to controversial interventions, like the creation of a cultural space on the parade ground, very aggressive at first glance, but when one considers that it currently has a cultural use, it is feasible. Being responsible for losing the meaning and historical legacy also involves acknowledging its value as an artistic object. San Carlos de Perote is a bastion fortification arranged in a regular square, each side 280 varas long. As it corners, it has 4 bastions aligned with the cardinal directions. 2 of the bastions have vault spaces that were used as the subterranean powder storage facilities, and the other 2 are solid. One of them was blown up by the army to prevent it from being captured during the US invasion of 1946. The fort is accessible through a winding path that crosses 2 bridges over the moat, one of them fixed and the other movable, leading to a single wooden door frame in a classical style according to the Syrian canon, topped with a lunite made from the Choluteca stone. On the inside, the axis of symmetry marks the 2 sides, 4 buildings for lodging troops and officials on 2 levels. The parade grounds have perimeter arcades with semicircular arches. Within the main building, there is a chapel with choir, altar, and a space for the sacristy. A perimeter circulation path separates the buildings from the embankments, which also contain vaulted spaces. The walls are mostly of masonry. They include irregular stones that are finished on one side to give the surface a finer look, or mixed masonry that includes quarried stones, river stones, and brick. They are all set in the wall using lime mortar. Lime was also used to cover the walls and arches. The bricks and lime were made in ovens specially built for this building. The structure contains semicircular, elliptical, tilted domes and segmental arches, and there are barrel, rib, lunette, and groin valves. Some of the arches have carved basalt keystones. The columns are made of red brick on the base, which carved basalt capitals, displaying of the embrasures is achieved through brick reinforced with basalt. An inscription of the 20th century intervention with the implementation of the rolling system of 1909, also known as Porphyrion vault. This building has not been properly valorized, but because of this lack of use, it has been condemned to a deplorable state with structural damage. There is currently no urban development plans. Growth has occurred by voracious advancing into the shooting grounds, which threatens its surroundings. Finally, the intervention in infrastructure of military engineers can be observed to the right on the plans for one part of the road to lay the best route due to region's complex orography. Dams built to create artificial reservoirs had to be situated in accordance with the local topography to take advantage of the river's flow and surrounding runoff. The construction of the Arispe Dam using lime and stonework to protect it from the current and follow the morphology of the rivers. As with the road of Toluca, where Mascaro was responsible for developing this bridge in Rio Simapan. No colonial fortifications were built in a completely regular form because they were adapted to local geography. Construction materials were shared in order to take advantage of their constructive qualities, such as the use of Campeche's limestone or the use of masonry based on a coral or mucara stone from the Veracruz Reef system. The constructive tradition that dates back to the pre-Hispanic times put into practice the use of sascab as an aggregate for mixtures with white earth, with lime and sand, and the construction techniques included secrets such as the use of seawater for the mixtures, as well as hardwoods. The refinement and improvement of the works was reflected in the drawings that the military engineers left us. In the development of this defense system of the Mexican and the Caribbean, there were coincidences and discrepancies in the characteristics in the different constructions. They tend to be symbols of the colonial past, which also strengthens their immaterial cultural component. Their value not only lies in their role as historical sites, but also because of their structural, architectural, and aesthetic aspects. When considering their current uses, an appreciation and understanding of their historical value should not only lead them to serve as backdrop to touristic activities. In the case of coastal forts, such as Atares in Cuba, the natural environment must be preserved. In the case of Acapulco, the natural environment has been preserved, as has the view of the coastal side. But construction has been permitted too close and too high to the fort of the land side. The importance of San Juan de Ulúa to Mexican history is overwhelming, and yet is not recognized as a heritage site. Development has often led to attacks on forts that have been more destructive than those of artillery. In more recent times, the primary problem is the container port with its gigantic cranes. But a bigger problem is the movement of enormous cargo ships so close to the building. Other challenges have to do with excessive tourism, as in Cuba or Puerto Rico, where the presence of cruise ships has completely transformed their historic districts. In Panama, economic resources and the passage of not only ships, but also nuclear submarines have transformed the environment. Never mind the interventions that aim to modernize this fort. In this case, the explosive growth of the city into countryside has substantially modified the space surrounding of the fort. In summary, if we wish to maintain or restore the importance and historical, aesthetic, and cultural value of forts, it's clear that we need to protect, care for, and restore the environment of each of these buildings, and be clear that they are expressions of the ideology and structure of the society that built them, without this implying a return to previous epochs. We must keep in mind that we preserve the past for the benefit of future generations. Military architecture fulfilled the task assigned to it, that of conserving the physical and spiritual integrity of its inhabitants by means of architecture. They were signs not only of power, but also of culture and social integration at the time of war, leading people to identify with these forts that situated on beautiful dominant locations and built with resistant materials have come down to us as part of the cultural repertory of our days. And it's precisely the historic, monumental, scientific, and artistic value of military architecture, its ability to communicate the circumstances of a long gone time, that has motivated this cultural venture, leading me to explore and share with you this call to value our military architectural heritage. Thank you very much.
Thank you very much, Monica, for the excellent presentation, the beautiful images, and of course, the helping us to understand the value of military architecture. Just for the sake of time, I'm gonna move on to our next presenter. I just want to clarify that earlier, because I was trying to figure things out, I say that we chose this topic of military architecture in the context of Memorial Day, but no, it's Veterans Day. Veterans Day that we want to honor here with this webinar. Anyway, so I'm gonna move forward and present to you formally Ray Rawlings. Ray and Marianne Rawlings are both civil engineers with PhDs, specializing in geotechnical engineering. They worked for the Corps of Engineers as research engineers at the Waterways Experiment Station in Vicksburg, Massachusetts, and the Cold Regions Research and Engineering Laboratory in Hanover, New Hampshire, for 25 years. Following retirement from the Corps, they provided subject matter expert consulting services to the Air Force Civil Engineering Center at Tyndall AFB. They have resided in Beaufort, South Carolina since 2005. And their long experience with military concrete airfield pavements and the military in general led them naturally to take keen interest in the old concrete Fort Fremont. Since 2007, they have provided historical research and technical advice to the Friends of Fort Fremont volunteer group. All right, without further ado, I pass the microphone and slides for Ray. Thank you very much, Ray, for being here with us. We appreciate it.
Certainly. Okay, can you hear me now all right?
Yes, I think so.
Okay. Let us proceed then. We had a little technical problem here. It's nice to be with you all this afternoon. My name is Ray Rawlings. I'd like to acknowledge my wife, Marin's contribution to this. Today, we'd like to take a look at the technical challenges of the construction of Fort Fremont, specifically the concrete portions of this. And this is an Endicott era fort. So what exactly is an Endicott era fort in the United States history? These were forts built as coast defense between about 1890 and World War I. After the Civil War, the United States was isolationist and their coast defenses deteriorated. The rest of the world did not sit still, though, and new threats developed, notably the steel-armored, steam-powered, heavily armed battleships. And these became the threat of the late 19th, early 20th century. As you can see on the right-hand side, that's what a fleet of modern ships did in 1882 to the city of Alexandria. And this became the concern of countries around the world. In 1882, Secretary of War at Endicott had a large board of engineers, officers, and industrialists look at the coast defense problem. They recommended modern fortifications at 29 different locations around the United States. And Congress began funding these in 1890.
Right.
Now this is, yes.
Right. Sorry, are you sharing slides?
Yes, I'm sharing slides. Can you see it?
Nope. Sorry.
Hang on, let me try again.
We're seeing we're seeing you, but not slides.
Oh, let's try it again. Now are you?
Yeah, now we
Got
can,
it? Okay.
we can see your screen. So you
All
will
right.
switch to presentation mode.
We'll move. Okay, is that better?
But much better. Now we are with you. Thank you.
Okay, thank you. I'm sorry. So where is this Fort Fremont? It's at an appropriately named place of Land's End on St. Helena Island, South Carolina. The nearest town to this, a city of any size, is Beaufort. We're roughly halfway between Charleston and Savannah. Port Royal is one of the great harbors of the world. It's very deep, it requires no dredging. And because of that, it had been a center of conflict going back to the 16th century when the French and Spanish built fortifications here. In the 18th century, it was the British. In the 19th century, it was the United States for the War of 1812 and the Civil War. And now at the close of the 19th century, we're going to close out 350 years of fortifying this Port Royal Sound with this new Fort Fremont. But it was not on the original list of 29 places to be fortified. And what has happened, you see on the map, Fort Fremont on is circled, and also circled up there is a Port Royal Naval Station. At the end of the 19th century, there was a Navy station here. Today, it's a Marine Corps training ground, but then it was a Navy station. And it had a coal yard, and it had a dry dock that was open in 1895 with plans to build 2 more. This was important because this is the biggest dry dock south of Norfolk and the only dry dock south of Norfolk, Virginia, that can take the U.S. Navy's new big battleships and armored cruisers that it's building and equipping the fleet with. On 15 February 1898, the Maine sinks in Havana. Tensions are increasing, and we're going to go to war with Spain in the near future. In April, the Army decides they have to fortify and protect this dry dock and this Navy yard, and orders come down to quickly build Fort Fremont. So it gets added to the list because of international events, namely the oncoming war. Now, Fort Fremont is included an administrative and living area, barracks, officers' quarters, NCO quarters, mess hall, lavatory, latrines, fire department, all the normal things you'd find at a small fort. Had 109 soldiers in the Coast Artillery Company, had 3 officers headed by a captain, and then a handful of support personnel. We're going to concentrate on the 2 batteries, on the construction of those. There's Battery Fort Nance that had rapid fire guns, and there was Battery Jessup that had 3 very large 10-inch guns. The third part of the military protection of this area is they would put electrically detonated mines out in the river. So it's a 3-part defense. Mines in the river prevent ships from moving up the river. The rapid fire guns, the 2 4.72-inch guns, prevent anybody from clearing those mines. And then the big 3 10-inch guns will engage battleships or heavy cruisers, whatever the heavy capital ships are. Here we see Battery Fort Nance. It's a relatively small concrete section with a large sand embankment in front of it. You see the guns up there on the top right. And then down below, you see the current Fort Fremont as it exists today, the 2 magazines where they stored the ammunition. Battery Jessup is a much more complex system. You see it's much larger. This will mount 3 10-inch guns. You see that up to your upper right. It would fire a 600-pound shell for about 8 miles. When the gun on the right fires and it recoils, in the middle you see there's a hole underneath that gun. There's a 30-ton lead weight underneath there. And when it recoils back down behind the concrete parapet, it lifts that weight up, reload the gun, change any settings you want, release the weight, it pops up, shoots, and then comes back down again. So it's a very clever system using just kinetic and potential energy to control the gun. At any point in here, you have at least 20 feet of concrete between the gun or the magazine and another 50 feet of sand, and where the enemy ships would be. So this is a much bigger undertaking to build all of this. And at the bottom right, you see the entrance to one of the magazines. You get massive amounts of concrete. This was built primarily with Rosendale cement. This is a natural hydraulic cement. These were not anything particularly new. They were in Europe in the late 1700s. It was also first used in this country probably for the Erie Canal. In the 1840s, the Corps of Engineers did a large amount of work testing different types of natural cement in the United States. And the cements that came from the quarries around Rosendale, New York, were selected as the superior source. So the Corps of Engineers would use only Rosendale cement. By 1898, the Corps had used Rosendale cement for 33 forts, 2 Navy yards, and 17 river, dam, and water projects. And in order to make this cement, you first quarry clay dolomitic limestone. You calcine this in a kiln at about 800 degrees centigrade, and then you grind it. This produces a fine powder that's got a very high pH. And at a high pH, silica and alumina in the clay, that's the contaminant in this dolomitic limestone, is leached out and is now available for chemical reactions. And that's why it's important that you have a dirty or clay limestone or dolomite rather than a real pure one, because you want that clay for this extra minerals. It will make a dicalcium silicate, which is a major cementing material for this. It's relatively fast setting, sets in about 30 minutes, but it gains strength relatively slow. So we're only talking maybe 1,000 to 2,000 PSI when you deal with natural cement like this. Portland cement was developed in England initially. The first U.S. production is in 1875, but now we're going to do a much more careful control of the composition. We're going to pick limestone and clay and marl and slag and things of this, so we control the chemistry. And we're now going to center this at a much higher temperature, 1450 degrees centigrade. And what this does for me is I get not just a dicalcium silicate, but I get another compound, tricalcium silicate. And this is going to give me more consistent setting properties and much better strength. So now I'm talking about strengths of 3 to 10,000 PSI, setting time around 45 minutes or an hour. I have more working time. However, Portland cement is about 3.5 times more expensive in 1898 than Portland cement. Portland cement is 3.5 times more expensive than natural cement like Rosendale. But if you look at this graph, what is happening in the cement industry in the United States, you see on the black dots there, that's natural cement production. And it goes along a slow increase until about the 1880s. And then as Industrial Revolution strikes, we begin to see a higher and higher demand for a concrete making material. We see the Portland cement in red starting to increase from 1875. Initially, we're getting most of our Portland cement from imports, particularly from Germany. But by about 1890, our production starts to increase. And then 1898, it really takes off. And just when Fort Fremont is being built in 1898, the production of Portland cement is roughly equal to natural cement. Because of its better properties, despite its high increased costs, Portland cement now takes over and dominates the market. Natural cement, like Rosendale, now decreases, and by World War I will cease to be the serious product used in U.S. construction. Okay, to tackle the construction of battery Fornance with the 2 rapid-fire 4.72-inch guns, this had to be put in rapidly. They were going to place mines. They're placing mines in the Beaufort River. They'll be in place in July 1898. And they got authorization to build something. They want these in place very rapidly so they can protect the mines. So they load up lighters or ships, barges essentially, with crushed stone from Charleston, north of here. They're ground these on the as near to the shore as they can get them along the Beaufort River, which is really an estuary. It's really salt water. They build a temporary trestle out to them, and then they wheelbarrow all that aggregate and cement 700 feet to where the battery Fornance is going to be. This is a very labor-intensive construction, and much of the labor is going to be supplied by the local Gullah Geechee Black community. These are mostly independent, small farmers who do subsistence farming with a small amount of raising cotton for cash. These are hard cash-paying jobs and are very important to the local populace because they don't have much access to that kind of money. It's a fairly coarse mix, 1 part cement to 2 parts sand to 4.5 parts stone. It's a significant amount of concrete, particularly when we realize that they're going to place all of this by hand mixing. And on the right-hand side, we see the process that they used, or the Corps of Engineers recommends for making concrete by hand. You spread the sand 2 inches thick in a rectangular pattern on the boards of the mixing platform. You spread your cement over the sand, 4 men with shovels turn and mix this. You form a basin in the middle, fill that with water, push the mixed material into the water basin, spread and turn twice. Now you got to make the concrete. You spread the stone on top of the mortar, sprinkle it with approximately 1 bucket of water, turn once and heap up for use. Takes about 30 minutes to produce. According to the engineering notes, they make the point that it's easily learned, but needs, and this is a quote, particular attention to the overseer. Having spent much of my professional life working with concrete on airfield pavements, that is just as true today on concrete construction as it was in 1898. So it can be done, but it's a very slow, tedious process. The battery cost is about $6,000, and the Portland cement, the small amount of Portland cement, is going to go into the blocks where the guns are actually going to be mounted, where they're going to be bolted into the concrete. They need that for the shock of the guns being fired. Battery Jessup is a much bigger undertaking, and for this, it's going to take more planning. Here, crushed and large stone from Greenwood, South Carolina, is brought by rail to Port Royal, then by lighter over to Fort Fremont. By this point, we've built a dock. We're going to use the same proportions as we used on Fort Fremont, but we're going to place more than 14 times as much concrete. Again, you see a large amount of this is Rosendale and some Portland cement. The Portland cement, again, is used in those blocks where those big guns are going to be mounted. Now we see this is much more expensive. It's $130,000. It takes them a total of 303 days to do the construction. Fort Fremont was built in 79 days. They had it up and operational with guns mounted by 28 June. So that was very fast. Here we're going to end up doing, because of the delays, we're going to do some hand mixing, but most of this is going to be a fairly sophisticated plant mixing and spreading operation. We'll look at that in a little bit of detail in the next slide. They had an unusual placement technique. They would place it 6-inch lifts, and then they would get, quote, large stone weighing from 1 to 5 tons placed on the concrete as thickly as good ramming would allow. So essentially, each lift of concrete, you place a big heavy stone on top of it, ram it in, and then place the next lift of concrete. And the idea was these big stones would help disrupt any kind of penetration by artillery shells. Then the sand fill is obtained from behind the battery, brought out to the front, where you have a minimum of 50 feet in front of all parts of it. And then, quote, fertile earth is put over the sand, and that's for growing grass. This is the layout of how they actually went about trying to build this big battery. You have a large dock where everything comes in, the stone comes in, the cement comes in that way. Going to the right up the beach is what they call a sand track. They're getting the sand locally. They would bring that local sand up. You had a small locomotive, so that would pull the loaded cars up to the storage bins, the concrete mixer. The engine for that would be used to pull those cars up an incline where they could dump them into the bins. The bins, when you're ready to mix concrete, would be carried up to the mixer in a elevator. It's a 4 cubic foot mixer, or something a little over a meter on each dimension. It's not a very big mixer for this much concrete. It's mixed, dumped out on a skiff. The skiff is pulled up what's called the traveling gantry track. That's a railroad track laid out there. Mules are used to pull this car up to where the gantry crane is at. Gantry crane now picks up the kind of skiff of concrete, dumps it in there, replaces it, and it goes back to be loaded up again. When you had to get the big stones, those were brought up what's called a rock track, and they were brought up to the gantry train, and again picked up by that train and then placed and then hand rammed into place. So it was a very organized system, but it was a lot of concrete to be placed. One of the big challenges we faced is, at this point, we really don't know a whole lot about construction technology. So on the left-hand side, I've tried to list some of the issues as we understood it in 1898, and then as we understand it better in the future and today. So the first thing is, when you look at the engineering notes from 1904 from their engineering school, they're debating whether the concrete mix should be dry, which some of the early testing in the 40s said you got the best strength. But to do that, you have to really spend a lot of effort ramming it into place. You get it to be creamy, essentially a semi-solid, or even a liquid. The drawback, if you place it as a liquid, that you have to have watertight form so the cement and water doesn't seep out. It's not going to be to 1918 that Duff Abrams sets out his well-known concrete law that the strength of concrete is a function of the water cement ratio. And essentially, the more water I add as a proportion of cement, the lower strength. So the liquid type approach gives you a low strength concrete. The drier you place it, the higher strength. Consolidation, we understand today, is crucial for both strength and durability. In this era, there wasn't much done other than hand ramming it. And that middle picture is from a battery built at the same time, about 40 miles away at Fort Screven in Georgia. Normally what they would do is when they would place the concrete, they put a mortar parge coat on the top, on the outside. So you got a smooth, clean, creamy, good appearing surface. In this particular photograph, the sand that in front of the battery has been stripped away, was used for road construction. Now we can see the quality of the consolidation in the concrete. You can see the lift lines, you can see honeycombing. So you can see that the concrete was placed with a lot of voids, which would affect both its durability and its strength. In that era, we had no concept of cycles of freezing and thawing on wet concrete would cause problems. It'd be the 1930s before we'd find out that we could entrain air, essentially using a soap in there to get these little tiny bubbles spread throughout the concrete. And that's what makes concrete durable to freezing and thawing when it's wet. There was no idea that this was even a problem when these forts were built. For Fort Fremont in this mild climate here in coastal South Carolina, we see very little damage. But if you go up to the forts in New England, you'll see a lot of freeze-thaw damage. Similarly, there's an adverse reaction called alkali silica reaction. That was unknown in that time. It'd be 1940 before anything would be discovered about that, and we begin to understand how to cope with it. One of the forts built up in New England has terrible alkali silica reaction, essentially causes expansion around the aggregates and it literally tears the concrete apart. Finally, reinforcing. We have to learn how to reinforce concrete and how to use it. The bottom photograph shows how it was done at Fort Fremont in 1898. You see the rusted remnants of a I-beam. The flanges that are sticking down at the bottom are just about completely rusted away. But those flanges were exposed and they were used to hold in place corrugated metal, which served both as a form and as sealing for the final construction for the interior passages, magazines, places like that. In 1908, a boiler room was added to Fort Fremont. And if you look at that closely, we find that now we're using Portland cement instead of Rosendale. Just 10 years after the original construction. And now we're seeing the reinforcing steel as bars, round bars, up in the concrete where we would normally place it in as we do now. Down at Fort Screven, 1899, a battery built down there, they were using bars up in the concrete, but now using twisted bar to try to get a better bond. It'd be 1950 before in the US we would really standardize deformations on our steel reinforcing, like you see on the right-hand side. So the things going on that we have to learn how to deal with this. But in 1898, they had to do the best they could, and some things worked better than others, and some things they missed. The Navy Yard moved to Charleston, South Carolina. This was a political move where a new dry dock opened in 1909. At that point, Fort Fremont no longer really has a mission. The troops are transferred out in 1911. It's put up for sale in 1920. Beaufort County acquired the concrete batteries in 2004 and built a history center there in 2021. In 2022, we had over 4,000 visitors, even though it's a fairly remote, small location. So we've been pleased with how many visitors stopped by to see it. So what's the significance of Fort Fremont? It's really a little tiny snapshot in time at the opening of the 20th century. It's important in the sense of military technology and political responses to that technology. It was how we reacted to the threats of the time. There's a whole history to that part of the story because Mary and I were both engineers. We were intrigued by the challenges of building these big concrete fortifications in a location like this. And we're seeing a lot of changes. And we should not think of this as a primitive construction. They produced electricity there for lighting in the magazines and for electric engines and for floodlights. They had that in 1899. Beaufort would not get electricity until 1910. And St. Helena Island around the fort would not get electricity to the mid-1930s. They had telephones that they used for fire control. They had the forerunner of a fax machine. They had running water. They had sewage. So in its time, it was very much a state-of-the-art facility. And to get it built, we're seeing some changes that are occurring right at this particular time of 1898 to 1900. We're seeing Portland cement completely replacing natural cement, which had been the go-to material for many years. It was used in the Brooklyn Bridge. It was used in the Erie Canal. It was used as foundation for Statue of Liberty. So it's been around everywhere. It's in the mortar at Fort Sumter and Fort Pickens. But now this is being replaced by new, better cementitious material. Our concrete knowledge is evolving. How much, we're going to have to learn how to make it more durable by consolidation and training air and dealing with problems like alkali silica reaction. We're going to have to learn how to proportion it better so that we understand how adding excess water to the mix is going to ruin the strength. And finally, reinforcing technology is evolving. First, we just put a steel I-beam out there. Then we go to internal bars, reinforcing it. Then we start twisting and deforming those bars to get better bonds. And where we have steel structures, we're seeing mild steel is now beginning to replace wrought iron. So I think that concludes my conclusion. I just wanted to introduce you to some of the construction challenges we saw there in trying to get Fort Fremont built.
Wonderful. Thank you. Thank you very much, Ray, for your presentation. And I think that this was an amazing webinar, having a complete overview of military architecture in the Americas. Unfortunately, we are pretty much out of time for questions and a conversation, but we want to remind you that you can get in touch with us at constructionhistorysociety@gmail.com for any questions or comments. We are the Construction History Society of America, and we are a group of practitioners and academics who are interested on construction history, and we do this type of activities, disseminating and presenting construction history research for conservation, preservation purposes, but also just for the sake of understanding better our built environment. So if you like the presentation, right, consider joining the Construction History Society. We are this organization that I just sent a link. You can find information about us. This, as you could tell, this webinar has been recorded. We have a YouTube channel, and this will be uploaded. It will be posted in our YouTube channel too. So we will have future webinars for sure. We will keep everyone informed. Again, thank you very much to Monica and Ray for their time and the wonderful presentations. This was an excellent also framework to commemorate our veterans this Veterans Day weekend. Thank you very much, everyone, and yeah, I hope to see you soon next time. Right. Bye-bye.
Thank you, everybody.
Bye-bye. Thank you.
Thank you.